Hey, what's up YouTube? I just want to do a quick demo here for probably the easiest way to generate some wiresheet logic with AI for the Niagara 4 platform. So I'm up here on GitHub pybog project. I'll link this in the description. But I would start off with downloading the code. Just easiest way is just to download a zip right from GitHub, and then jump over to ChatGPT. Let's put ChatGPT into agent mode here. So let's test this out. What I'm going to do is add this, upload this zip file right to ChatGPT, and then with agent mode, this is like an AI agent mode. It's pretty cool. Like ChatGPT will start running agent tasks. I think it spins up its own sandbox environment, and you can tell it to you can upload anything to it. Like I've been uploading zip files of GitHub projects in the AI agent, whatever running in ChatGPT. It explores the GitHub context in the zip file, and it should know just what to do with everything that was zipped up in the pybog project. So I'm gonna tell ChatGPT, it'll read the README of like what the project is, and then also there's context in a folder. This is some zip files, or sorry, it's text files. It includes everything that I've been doing in pybog, just all my Python examples of how to make wiresheet logic with Python, and it's very long. It's a couple thousand lines long, and it's, in terms of tokens, I think it's about 60,000 tokens. Here we could actually test this real quick. So I'm just going to go to OpenAI token counter, and let's see how many tokens it is. So let's see, if I come over here, I can actually copy the context right from GitHub. See how many tokens it is. And yeah, so we're up to 40,000 tokens just of all the examples. So with the other text files, I think it's probably closer to about 50,000. So it's, the reason I'm telling you this, it's like, it works for ChatGPT because it has a really big context window in terms of tokens. I think ChatGPT can handle up to 128,000 tokens in its context window before it'll start losing its brains. Basically, it'll start losing first in, first out. If you feed it too much information, it'll just start, it can only handle so much. Some of the smaller, older miniature models can only handle about 4,000 tokens, but it's getting better and better. So yeah, this is something I'm working on, is to be conscious of how many tokens I'm feeding to the large language model. So all right, let's give this a whirl. So in pybog, in the context folder, I'm going to tell ChatGPT agent mode to look at these text files. One of them is some information about kit control, about what it is in the Niagara framework, and then these are also some text files. What I'm actually still working on a little bit is better way to do context. It doesn't have a full-blown context protocol server yet, but I'm just running with this for the time being. Future examples will have full-blown model context protocol, but that's not ready yet. So I'm just kind of I'm still experimenting with fast MCP, but so basically I'm going off of like I think this is a standard. There's two ways for the LLM friendly documentation, and one is this LLM text, and one is LLM full text. So it's the entire documentation for your project. Note that it may exceed the context window of your LLM. So I know for at least ChatGPT 5, we should be fine. Okay, so enough explaining that. I zipped up my pybog project from GitHub, and I'm just going to make something up here. I haven't even tried this, so let's might be a little experimental, but so I'm just going to say, please make me a wiresheet logic and log file to download once you are completed of a central plant. See, I'm just making something up here. So let's make something up. So I have a central plant with a boiler and a chiller with variable pumping for both systems. There is a hot water pumping system with 2 pumps and a chilled water pumping system with 2 pumps. Each hot and chilled water has a differential pressure sensor to control the pump VFD speed to a diff pressure set point of, let's say, 20 psi. Please make me wiresheet logic to run the plant as well as outside air temperature enable set points to enable the heating and boiler command at 50F and below, and let's say 65F and above for the chilled water. In between 50 and 65F, the plant should be off, because we shouldn't need heat or cooling in that kind of a range. So I'm just making this up. So it's just a fake sequence for a chilled water plant. And I'm going to also say something. Please use hysteresis in the enable for a heat or chilled water plant. I'll say system. Please provide a output for a boiler or a chiller as well. So I'm just making something up, thinking and typing. Please review the context folder in the zip and readme. Alright, and let me download a bog file, which I'll test on my end. Thanks. Okay, let's see. Agent mode is selected. I think, remember, just to make sure agent mode is selected, or else it won't I think this should return a actual bog file to us, but if it's not, it may not. So what agent mode is doing is it'll actually run some Python scripts. It'll make the Python script correct it if it needs to be corrected, and download a bog file. All right, here we go. Here we go in agent mode. So right now what it's doing, it's setting up its virtual environment. Here we go. I think this is kind of neat that it's you can actually see a little bit behind the scenes, like what the agent mode is doing. So it's so yeah, now it's like looking at examples, designing the plant control logic. So basically it's using all of the Python code examples. I'll probably do like another YouTube video soon here for more of like the theory of like what's going on in the Pybog project behind the scenes. So that's coming. But right now I think this is like the easiest way to probably generate some wiresheet logic. What else is coming here? So looks like it's still working. I'm using this actively in optimization projects. So I'm not actually spinning up wiresheet logic here. Like this example was more traditional controls contracting. I'm actively doing like guideline 36 air handling unit trim and respond algorithms, which is something I'll go into detail on the later examples, but I'm actually using Pybog to generate and test guideline 36 algorithms for air handling units. Maybe if we just look at Pybog, for example, for a couple minutes while that's running. So these are like example Python scripts that I've developed that'll go into greater detail. So most of these are just for optimization purposes, but I want to add in some more examples of just generic HVAC sequencing, because I think that would be useful. There are some contractors, like Honeywell contractors, for example, will use a JACE pretty heavily just to do their everyday air handling unit logic. Will actually be a JACE with actually wiresheet logic, where some contractors will actually use like a field level device. All right, so what is it doing? So it looks like it's still working. It's going a little slower than I thought. So it looks like it's actually looking at data from the internet, even though it looks like it's trying to get data from the internet. Maybe it's referencing its own documents. I'm not really sure. I have tried to see if ChatGPT agent mode, if it can git clone a repository, and it said it does not have that ability, but you can upload a zip file. Oh, it looks like it's done. So voila. So it looked like it searched. This is interesting. So it worked for 3 minutes, and here we go. So all right, I'm not entirely sure this will work. So all of this is like very experimental. So okay, let's see what it did. Okay, here's my bog file. Central plant bog. Alright, so here we go. Here's our central plant bog. Let's go over to my workbench example. These are my air handling unit trim and responds. Maybe I can show you these too. So here we are in workbench. I'm in an office environment. I'm not on a JACE or in the field or anything like that. So yeah, definitely heavy office environment testing for the field. So here we go. Here's my central plant bog file made by AI. So let's see if it'll parse. Ooh, it parsed. Once in a while, there can be like a bog in the code that used to generate the bog file, and it'll error out here. You'll get like a big Java error that it was unable to parse the file, but okay, let's see what this looks like. So you can even look at it here. Or else I have a running station for testing purposes. Let's paste it in there. Central plant. All right, so let's see. AI made some. I have to fix this. This is just kind of like a quirk that if it puts logic in subfolders, it staggers them like this, and I'll make some kind of a fix to kind of neatly put everything. But like what it'll do is it'll put all of the inputs on this side and all of the outputs on this side, and then it'll start putting stuff in subfolders. So this is wiresheet logic created by AI. It does lay it out kind of nice and neat. There is some in the pybog project, there is like some rules in there that it has to lay out 15 steps on the X and 5 on the Y. So yeah, it does lay out the logic blocks kind of neat. Hot water loop, so looks like it put a PID in there for us, and a numeric latch from the PID output. I'm not sure why it did that. Chilled water loop, so put a PID in there for that too. So okay, let's try it out. So let's see what we got here. You could even be real specific, and you could tell it what you want your point names to be, and it'll put all that in there too. But this is what I'm doing. Like when I'm testing out pybog, I'm having it generate a Python script, and I run the Python script myself. But in agent mode, it did all that and let you download the block file directly. Okay, so here we go. Let's drag around our outside air temp. Okay, so this is our outside air temp. In the field, we would be linking this up to the actual sensor for the building. Okay, 60 degrees F, that's in degrees Fahrenheit. That's kind of on the high side of the economizing end, so we shouldn't really need a chiller, and we shouldn't really need a boiler. So let's see, so our logic should be running. Boiler's off, chilled water's off. Some of these points aren't really, maybe I'll put the hot water pump, hot water stuff by the hot water, chilled water here. These must be speeds. Chiller command. So this is just like a basic example, and it looks like it's off. Hot water pump enable, set point, hot water pumping differential pressure set point, chiller differential. Okay, so it looks like it here's our 65 degree set point to enable the chiller. Okay, so my assumption is like if we do a set, let's see, 70 degrees, run the chiller. Did the chiller run? Ooh, I do see chiller points. Hopefully these were false before that. And then a chiller pump. Did it get the PID right? So where's the chiller? Chilled water. Let's simulate some low differential pressure and PSI. Does our PID work out of the box? I don't know. You could have to monkey around with it a little bit, but maybe future values will get it better. Okay, let's see if it got the PID backwards. All right, so the PID doesn't work out of the box. Just looking at chilled water, differential pressure, and set point. Let's see. So let's see if I put. Here's hot water. Well, let's see if it'll start the boiler. So let's simulate the outside air temperature going cold enough to start a boiler, and chiller goes off and heat comes on. Okay, that's good. All right, so and still like the pumping logic didn't, or the PID didn't work for the boiler. Let's maybe troubleshoot that for a second. I'm not gonna put too much time into it. So it looks like our pump speed outputs didn't work. I don't know what this is. Why did it put a numeric switch? Regardless, let's see. So here's our PID. So it looked like it is that right. So the control variable is 10 and the set point is 20. So if I just go back up here, yeah, 10 and 20. Oh wait, so right now we need our set point to be 10 and the differential pressure sensor to be 20. Okay, so right now we should be under set point. We should have a speed, speed command. The PID should start ramping up. So, oh, actually, I think I might see the problem here. Looks like they're, for whatever reason, we're trying to, so it did put some values for a prop and a constant. So this is 0. Why is it 0? Anyways, maybe I'll have to fix this a little bit. There might be just a bug here that it's not feeding in the values to the PID. Okay, so I do have a working example of this where I have tested some PIDs and they do work okay. So, but this is like a perfect example of, might be a slight bug. So I would open up a GitHub issue and say, check PID. All right, so regardless, it looks like there just is an issue of the PID not ramping up. So I might take a little closer look at this. There could be some problems. Maybe these numbers are a little bit too low. I can't remember off the top of my head what they should be. It seems really odd that they're not feeding in here. So there could just be some small quirks in here that why the PID isn't working. So regardless, yeah, this is how the wiresheet making what it's like making wiresheet with AI. So might be a couple bugs, but as we shown in the making the central plant logic, but all in all, I think it's promising. So like I said before, like I think this could be a neat tool for generic HVAC sequences, and then I'm mostly using it for optimization, but the idea would be to just quickly create wiresheet logic, and yeah, like in 10 minutes we made something that could have taken an hour or two. So and as the complexity grows, I think that really complicated central plants that like would take a day or 2 days, creating wiresheet logic, like AI tools like this should be able to cut that time down to like an hour, maybe 2. So here it is, more to come on it. So it's I'm also trying to spin up like just like a generic ChatGPT mimic on the internet. So like you'd be able to just chat with the pybog maker and have a bog file returned to you. So it's coming. Thank you for the examples. Watching this example, and I'm also looking for some contributors. So like anyone that's interested in testing this out, run it through its paces. It needs to have things tested, and then finding like a little bug like that the PID isn't ramping up. Just report little things like this. But I think it does kind of have some cool features of like, it made this in seconds. So it would take the human to do this, hours and minutes, what AI can do in seconds, and then it always takes the human to thoroughly test things. All right, thanks all. So talk to you soon.